All right, sorry guys, I got called away for ninth grade PSAT there for a little bit, so starting a little bit later than normal. All right, luckily for us, it's a kind of easy day. All right, let me share this with you and get started. Okay, here we go. So you took your test, or you are taking. I'm teaching this on a Tuesday, so you guys are. I think one person actually did it. And the rest of you are taking it physically as I'm teaching this class on Tuesday. You are taking that test, so you're probably watching this test on Wednesday, which means that you're physically here in school. Meaning like you're actually going to take this on Thursday, right? Because you're doing the PSAT today. So hopefully that wasn't too confusing. All right, here's your homework. I don't think I have anyone live right now, so I'm gonna just go ahead and hit that on pause, and I'm gonna speed through this. Not speed through this, but you get the idea. All right, the distance formula. Anybody remember doing the distance formula last year, Algebra 1? All right, let's see. All right, quick coordinate plane review. Well, remember the coordinate plane, the Cartesian coordinate plane made by René Descartes, breaks it into two number lines, an x-axis, number line 0 at the middle, and a y-axis, 0 at the middle. For the y-axis, the positive numbers are above and the negative numbers are below. And for the x-axis, as the number line would generally appear, meaning negative numbers to the left, positive numbers to the right. Both number lines are joined at their 0 points at right angles to each other, and it makes those four quadrants 1, 2, 3, 4. All right, the origin is at the middle, the axes, as we stated, and the quadrant. So there's your coordinate plane review. And by the time you get to geometry, this is all solid knowledge for you. So think about this. If I gave you 2 points, A and B, do you see them there at the top, A and B? And I ask you, what's the distance between them? Well, it's already listed there. One way to calculate the distance would be to actually count the number of squares, right? 1, 2, 3, 4 from left to right. Great, that's pretty easy when it's a horizontal line, that one right there. But I do want you to notice that if I labeled the coordinates of point B and A, X, Y, and I subtracted the X values there, so the X value for point A is 3, the X value for point B is -1, and I subtracted those two ones. Check it out. Look, I get positive 4. I get the same thing. So if it's a horizontal line, you can simply subtract the coordinates of your X values for the endpoints of the segment, and it'll tell you how long it is. Now, does order matter? And it turns out, well, it's sort of. If we subtracted those numbers in the reverse order, in other words, B minus A, the X values, so -1 minus 3, well, we don't get 4, we get -4. So the way we get around that is we say, well, the absolute value of the difference of their X values. And that way it doesn't matter the order. So if you take the absolute value of the X values, and it's a horizontal line segment, well, then you get the distance. Well, that's kind of neat, right? So I don't need a graph. I just need the 2 points that make up the endpoints of that segment to calculate how long that segment is, as long as it's a horizontal line. Now, if it's a vertical line, see the C and the D there? If it's a vertical one, well, we're not going to mess with the X values. We're going to mess with the Y values. And it's the same story. Notice I can count the number of squares. There's 3 squares. But then instead of messing with the X values, I could simply mess with the Y values. Watch it. I'm going to look at the Y values. 1 minus -2 is 3. -2 minus 1 is -3, but take the absolute value, we get 3 units. So that's all nifty, but it does require us to have either a horizontal or a vertical line segment in order to calculate the distance, and then we have to graph it. Seems kind of strange. Also, what would happen, it's the big but, what would happen if it wasn't horizontal vertical, but it was diagonal like this one? We can't count squares any longer, but what we can do is use something from the previous chapter. Remember, the previous stuff we did was on Pythagorean Theorem. Well, we could use the Pythagorean Theorem and make a right triangle. Look what I'm doing here, right? Drop a vertical from that upper left point, right a horizontal from the lower right point, where they come together would form a right angle, make a right triangle. And now we can simply count squares for the vertical segment there, the dashed red line, and the horizontal segment. Literally, I'm just going to count squares. It's 6 squares across, and it's 10 squares high. Well, I just use Pythagorean theorem. 10 squared plus 6 squared equals that final diagonal distance right there. So do the math right there. I'm not going to spend time on that particular portion, but we get that it's 2 root 34. All right, cool. Really easy to do. Okay. What's the so what about this is the fact that, well, what happens if we don't know? And I'm basically going to do a proof for you right here. So this is a visual proof. So let's imagine that I have an X and a Y axes and there's a segment somewhere. Now, granted, I just put it between quadrant 1 and quadrant 4, but it could be anywhere. I'm not going to claim that those two endpoints are anywhere specific. They're just somewhere on the coordinate plane. So the two endpoints of that segment that's blinking right now, somewhere on the coordinate plane. Okay, cool. We're going to call that distance suspiciously D for distance. And then that lower left point, we don't know where it is, so I'm going to call it X1, Y1. And suspiciously, I will call the upper right one, I'll call that one X2, Y2. For those of you that already know the distance formula, you kind of know where this is going. All right, we're going to do the same thing we did the previous one. We're going to use Pythagorean theorem. So I'm going to drop a vertical from the upper right point. I'm going to draw a horizontal from the lower left. So I'm going to draw that through construction, just draw a horizontal and then draw a vertical where they come together would make a right angle. And let's see, what would be the point where they come together? In other words, could I figure out what is this point right smack there? Well, let's think about that for a second. That point right there, well, it will be the same left and right as the top point. So therefore, its x value would still be x sub 2, but its y value would be the same as the y value of the lower left-hand point. It would be y1. So that point right there, think about it, it's the same distance from the x-axis as the first point, and it's the same distance from the origin as the second point. So that's why that red dot right there is literally x sub 2, y sub 1. Cool. Now we can use Pythagorean theorem. So the Pythagorean theorem says that we got to do a squared plus b squared equals c squared, right? So I'll call that side A, I'll call that side B, and well, we'll call D still D. So even though I'm going to start off this way, I'm also going to take this formula and write it backwards. Are we okay with that? All I'm doing is writing it backwards. You'll see why here in a second. But wait a minute, I called C D, so I need to change that so it says D. All right, so I took the original Pythagorean theorem, flipped it around, and called CD. All right, so far so good. Well, let's see if we can figure out how long A is. Well, A is, well, we just figured out in the previous slide, it's a horizontal segment, so we just subtract the two x values, take the absolute value. So if I subtract the two x values, take the absolute value, and then square it, and then to find the B, that would be the y value subtracted absolute value squared, right? Just using Pythagorean theorem here. But let's think this through. Let's see, x sub 2 minus x sub 1 squared. Anytime you take a number and you square it, it ends up being positive. So I guess the point I'm going to make here is that both of these, both for the x values and the y values there, I'm squaring it, right? You see the parentheses then squared? So I don't really need those absolute value symbols, right? I can leave those off because squaring a negative or squaring a positive is always a positive value. Remember, the only reason we had those absolute value there is because sometimes when you do the subtraction, you can get a negative number, and we want a positive number. The squaring does the same effect, so I don't need to write those absolute values. I could leave them in if I wanted to. Well, what was the original question? I've kind of forgotten. Oh, yeah, that's right. I'm trying to find out how long D is. Well, my formula right there says D squared, so all I have to do is take the square root of both sides, and boom, the square root of D squared is D, and there is that formula that you remember from algebra last year. This is the distance formula. The distance formula is the big long square root symbol. You take the x values, subtract them, and square them, plus take the y values, subtract them, and square them. And by the way, I did not show you this last year, but we have just did a proof, and well, it's called deriving, right? In other words, I somehow get to the formula from using some logic. Well, that's kind of what I just did right there. So that's theorem 13.1. It's called the distance formula, and it is something that you've already used last year. This is your second look at it. It turns out we will use the distance formula just like we use Pythagorean theorem a lot. And oh, by the way, this is the Pythagorean theorem formula. This is literally a squared plus b squared equals c squared, just in a different form. What's its purpose? If I'm given a segment, I can now calculate its distance. I don't need to graph it. I just need the points that make up the two endpoints, right? In other words, I need point 1 and point 2, where both of those points are the endpoints of a segment, and then it's just plug and chug. If you remember doing this last year, the key here is labeling and just plugging the numbers in and just carefully working through the calculation. Plugging the numbers in and then carefully working through the calculation. All right, since no one is live right here, I'm going to move on. If you're not live, then hit the pause button, write it down, make sure it's in your book of truth. All right, so I'm going to show you on a nice simple one. By the way, look, I could do 3 squared plus 6 squared, find out what that is, and take the square root and find d. But imagine that I only gave you the two endpoints, -4, 2, and 2, -1. Do you see the two endpoints there? Imagine if that's all I were, because that's what's going to be homework. They're not going to give you something that looks like this. So I have my two endpoints. I simply need to plug those values in. And it doesn't matter which is 0.1 and 0.2. I'm going to call -4, 2.1 and 2, -1.2. Please, please, please label. Labeling is where it's going to set you up for success or set you up for failure. Notice it doesn't go x1, x2. It goes x1, y1, x2, y2. You see how that label goes? If I'm going to call that first one 0.1, then that would be the x value of 0.1 and the y value of 0.1. And the second one, well, the x and the y values of 0.2. Now it's just plug and chug. For those of you that, I don't know, maybe you had a horrible algebra teacher last year and you didn't learn this, then you're going to need to make sure you understand where I'm plugging in those values. Notice the formula says x sub 2. So I look for x sub 2, that's 2, minus, formula says minus, x sub 1 is a -4. So that's why I have those two negatives running around. Close your parentheses, square it, plus y sub 2. Y sub 2 is -1, minus, the formula says minus, and y sub 1 is a 2. Now it's just a matter of just doing a little bit of math. Two negatives turn into a positive. 2 plus 4 is 6. -1 minus 2, -3. And then I square everything. 6 squared is 36. -3 squared is 9. Pause the video, rewind it if I'm going too fast for you. 9 plus 6 is 45. You're in geometry now, so check for perfect squares. Yeah, 9 is in 45. 9 times 5 is 45. So that would give me 3 root 5. Wow. Seems like a lot of work, and it is, but it's not too bad, especially after you do a bunch of these. Now, 3 root 5 is what we call the exact answer. That means we're not typing that into a calculator. If you do type that into a calculator, remember, square root of 5 is irrational, decimal number that goes on forever. So you got to do a little bit of rounding. So the approximate answer, if you were to type in 3 times the square root of 5 into your calculator, you get about 6.7. Now, why would you need both of those answers? Well, if it's just math, I mean, we're just literally just doing some math. 3 root 5 is a perfectly fine answer. If you had to cut a piece of wood, like if this was a shape or something, you're trying to cut it, well, you need, I mean, there's no 3 root 5 on your ruler, right? There is a 6.7 on your ruler, though. So that's why sometimes you'll see for homework or whatever, it'll say, write the approximate answer. That means, yank your calculator out, or they'll say, leave it as the exact value. Exact value has an equal sign, approximate has the approximation symbol. I guess we should do another one, right? All right, now you're going to see my pattern, right? How I line numbers up. If you don't like the way I line the numbers up, you can line them up whatever way you like, as long as you label them correctly. So for me, I start off with my 2 points there. I label one of them as 0.1, one of them as 0.2. And then I just go to town here. So the formula says x sub 2. So the x value of, remember that sub notation, right? Subscript right there, that's 2 means of 0.2. So the x value of 0.2 is 2, minus the x value of 0.1 is 3. So 2 minus 3. The y value, let's see, y sub 2 is 4, 4 minus 8. Now we just basically go to town on the math. 2 minus 3 is -1, 4 minus 8 is -4. We like that square, and it gets rid of those negatives. That's going to give me a 1 and a 16, right? -1 squared, -4 squared. That's 17. So there's no perfect squares in the square root of 17, and you're done. Tonight for homework, they're going to give you 2 points, and they're simply going to say, what's the distance between the 2 points? Well, this is the process you're going to use. So how many steps? 1, 2, 3, 4 steps to get to an answer. 5 if you count labeling. but it's not too bad. All right, square root of 17 is your exact answer. The approximate answer, to plug it into your calculator, you get 4 points. It's not going to ask you exact or approximate. It's just going to say, what is the answer? So for tonight, leave it as the square root of 17. I just want to get you guys used to seeing these words, exact and approximate. One more time. All right, for those of you that want to work at your own speed, pause the video, plug in the numbers, see what you get, and then hit play. Everybody else? Nobody live yet. Nobody's live. I'm going to plug in the numbers. The x value of 0.2 is -4 minus, don't forget there's a minus sign in the formula. That's even before you get to the point. And while the point's negative as well too, that's why you get these two negatives right there. -4 is the x value of 0.2. -1 is the x value of 0.1. And there's a minus sign in between them. So you get these two negatives. Y sub 2 is -6. Y sub 1 is 3. So -6 minus 3. Two negatives turn into a positive. -4 plus 1 is -3. -6 minus 3, -9. Square both of those. That would give me 9 and 81. Add those suckers. 9. Ooh, there's a square root of 9 in 90. 9 times 10. So that would be what? 3 root 10. There's your exact answer. Approximate answer, 3 times the square root of 10 is approximately 9.5. Like I said, why both answers? You go to Home Depot and you say, I need a piece of wood that's 3 root 10 inches long. They're going to look at you funny. But if you say, I need a piece of wood that's 9.5 inches long, well, they can do something with that. All right, here's a cool example. I got a circle somewhere on the coordinate plane, right? I drew a circle. It's got a radius of r. It's got a center of AB. And there's a point on the circle. We'll call that point P, and it's at XY. Watch this. This is pretty cool. If I ask you, what's the radius of this circle? Well, I don't know. It's not labeled. There's no values whatsoever. It looks like it's in quadrant 1, but I'm just going to claim it's somewhere on the coordinate plane. Well, how do you figure out the distance of a radius? Well, it's the distance formula, right? So let's plug in what we know. Point 1 is AB and point 2 is XY. So there's my labeling. Now I just type in those values, right? Don't be worried that there's no actual numbers here. There's just values. So I type in those numbers. So x sub 2 is x, x sub 1 is a, so x minus a, and then y minus b. Cool, right? Well, this didn't really get us anywhere, but it turns out that if I want to get rid of that square root symbol and I square it, what's in yellow there is an interesting looking formula. And it turns out that what's in yellow, well, what did we start with? We started with a square with a radius and a center and a point on that circle. And it turns out that what's in yellow there is, believe it or not, that's the formula for a circle. Like if you want to draw a circle, that's the formula that you use for any circle of radius r and center AB. Regardless of where the circle is on the coordinate plane, that in yellow is the formula. Oh, by the way, I just derived it, and that's a proof. All right. So the formula for a circle of radius r and center AB is what's there in yellow. We better write that down. In fact, that is theorem 13.2. So the formula for a circle, yeah, there's a formula for it. The formula for a circle is r squared is equal to the quantity x minus a quantity squared plus y minus b quantity squared, where a and b are the center and r is the radius. Notice it doesn't say r squared is the radius. It says r. Okay. Once again, if you need time, hit it on pause. If not, we're moving on. We're going to play, I think, 3 reindeer games today. Yeah, 3 of them. So basically games using that formula I just showed you. So they're going to give you a formula. Looks suspiciously like the formula for the circle. Notice I'm not saying it's the formula for area of a circle. I'm saying it is a circle, right? And it's going to ask you questions. It's going to say, find the radius and the center of the circle. So how do you do it? Well, you compare the given formula with the formula for a circle. There's a formula for a circle. Well, notice immediately the center, well, it would be the number. Let me indicate this. It would be the numbers that are indicated right here. Notice our formula has minus signs in, so we need minuses. So the center is kind of easy. It's at 3, 4, right? 3 is where A is, and the 4 is where B is. So therefore, my center is at 3, 4. Is it really that easy? Oh, yeah, it's really that easy. Well, how do you find the radius? Well, where is the radius? It doesn't say r, but it does say r squared is equal to, let's see, on our other side, let me do this one in red. The thing that's in the position of the radius is this number 25 right here. So I simply set up a quick equation, right? R squared is equal to 25, and I solve that. Well, how do you get rid of squaring? Take the square root of both sides. So therefore, r is 25, and that's the radius. Is it really that simple? The answer is yes, with one caveat. Sometimes they will mess with you, not on the radius, but they will mess with you on the center. Let me show you that one. So look at this one, right? Well, there's the formula. They're going to say, where's the center and where's the radius? Well, remember, the center are these numbers always right here. But the formula says I got to have minus signs, and well, we got a problem. Well, the 6 has a minus sign, but the 2 does not. So the only way you're going to get a minus sign here, right, is if A was a -2. Think about that. If the formula already had a minus sign in there, it would be minus -2, and 2 minuses make a positive. So here's the trick. The center will always be the numbers there that the arrows are pointing to. It's just that you got to make both of them fit into the formula where you get a minus sign. How do you do that? If it's already minus, it stays that number. If it's positive, well, then the answer is going to be the opposite of that. In other words, negative. So where's the center? Not at 2, 6, but at -2, 6. Right? Can you see why that would work? If you plug in -2 into the formula in yellow there, you'd have -2, which would give you a +2. So the pro tip is you look at these two numbers right here. If it's positive, the answer is negative. If it's negative, the answer is positive. Who did I confuse by saying that? No one? Good. All right. So what's the radius, though? The radius is, well, it doesn't tell us, but it does say that what's in the position of r squared is 125. So we simply write r squared is equal to 125 and solve it. Or in other words, just take the square root of that number. Well, the square root of 125 is, you remember that one, right? We better see that math. You better see why that's true. 5 root 5, where'd that come from? Well, remember, the square root of 125, I thought I had this written, but I guess I didn't. Square root of 125 could be written as 25 times, let's see, 25 times 4 is 100. So 25 times 5 is 125, and square root of 25 is 5. So that's where the 5 root 5 came from. Questions? All right. So that's our first reindeer game, pretty easy. Second reindeer game is this. They're going to give you a formula of a circle and ask you to graph it. Well, how do you graph a circle? Well, step number 1, you got to find the center of the circle. So the center of this circle is at, remember, if it's negative, that's the number. If it's positive, then the answer is negative. So the center of this circle is, be careful, is at 1, comma, not 2, but 1, -2. Can you see that? 1, -2? You following the pattern now? If it's negative, it stays that number. If it's positive, it becomes the opposite. So I know I have a circle at centered 1, -2. 1, -2, and the radius, where am I getting that from? A radius of 3, because it says 9 right there. Well, remember, that's what r squared is. So r would be the square root of 9. You catching on now? Pretty easy, right? Okay, so how would you draw this? Well, you'd start with the center, 1, -2, so put a dot there. The radius is 3, so let's see. If I go to the right 3 squares, I would get, or go up 3 squares, I get that dot. I go right 3 squares, I get dot, down 3, left 3. Well, that makes a square. That doesn't make a circle. So how do you make a circle? We go back to what we haven't used in a while. We grab our compass, not our protractor, but our compass, and we measure, literally put the compass from that black dot to any one. In fact, you don't need to draw all 4 red dots. You just need one of them. Just go either up 3 or right 3 or down 3 or left 3. Measure that distance with your compass and then draw your circle and you're done. Pretty cool, right? All right. There'll be a couple questions like that tonight for homework. I'm only going to show you this one, so let me back up. How do we do this? Step number one, find the center. The center is at 1, -2. Why not 1, 2? Well, remember that 2 there in our blue formula is positive. We want the opposite of that. So we want -2. The radius is not 9. That's what r squared is. So you take the square root of 9, you get 3. We put 1 dot at the center. We put 1 dot, and then we take our compass and we draw a circle, right? We measure that between those 2 dots, the black one and the red one, that would be 3. And it doesn't have to go above. You could have gone to the right first. I usually probably go right first, and then you draw your circle. You do not need to draw those 4 dots, but you can if you wanted to. Okay, I said 3 reindeer games, and we're down to our last game. So our last game is this. It's going to say write the equation. So it's basically the opposite of what we did on that first reindeer game. So the first reindeer game, I gave you the equation. You found the center and the radius. Now it's just the opposite of that. I give you the center. I give you the radius. You write the equation. Well, it's not too bad. All you do is plug the numbers in and do whatever it says. Well, it says the center is at -3, 6, right? So that would give me what? +3 and a +6. Remember, it would be the opposite of those signs. And then we simply square the radius. Well, 4 squared is 16, and you're done. Is it really that easy? Yes, it's really that easy. It is really that easy. Maybe one more. All right, let's see. Center of 10, -6, and a radius of square root of 7. Well, all we do is plug those numbers in. So x is 10 and A is 10 and B is -6. The only ones you mess with are the ones that are negative, and you write a positive. So it's a 10 and a 6. And then we square the radius. Well, what's square root of 7 squared? So that would be the square root of 7 times the square root of 7, right? Square root of 7 squared would be the square root of 7 written twice. Or squaring gets rid of square rooting, so you're just left with what? 7. For those who did the square root of 7 times the square root of 7, that's the square root of 49. Square root of 49 is 7. All right, use the power of the review button to rewind the video, whatever it is that you need extra help on. Also send me a chat if there's something you didn't understand. We'll do, like, I guess maybe one more. See, the center is at -11.3 and the radius is 2/3. Don't panic just because there's a fraction. It's not as bad as you think. Remember, the negative ones become positive, so that's going to be what? X plus 11, y minus 3. You see where I'm getting that from? X plus 11, the opposite of -11. And then I got to square, not square root, but I got to square 2/3. Well, remember, squaring 2/3 means square the top and square the bottom. So 2 squared is 4, 3 squared is 9. So we get 4/9. Why did I write? That looks horrible. I should have been a 2. All right, that's better. All right, questions on anything, any one of those 3 reindeer games? All right, I do have one more cool thing. I'm going to run through this real quick. This is just additional stuff. It's not in the book. How do you use your graphing calculator to graph circles, right? So graph a circle of radius 4 whose center is at the origin, right? If the origin is the center, well, the origin is 0, 0. That means A and B are 0. In other words, x minus 0 or y minus 0 doesn't do anything. You're just left with x squared and y squared. Well, r squared is supposed to be, well, radius is 4, so that would be 16, right? That's pretty simple. Now, what I'm going to do, because the graphing calculator can only be graphed if you set y equal to it, I'm going to solve for y. So watch when I solve for y here, over here, scratch work. Let's see, I'm going to move the x squared to the other side and subtract. So I'm subtracting x squared from both sides. So I get y squared is equal to r squared minus x squared. How do we get rid of squaring? We take the square root of both sides. Why is there a plus or minus? Remember, there were 2 possible answers to when you square something. You know, -3 squared and +3 squared are both 9. That's why there's a plus or minus there. And this in yellow is what you would have to type into your calculator if you wanted to graph it, if you want to mess around with this. Now, your calculator doesn't have a plus and a minus button, so we separate that into 2 equations. One where the square root is positive and one where it's negative. Not inside negative, but outside. So in yellow, there is what you would type into your calculator. What was our radius? Our radius was 4. So that would be what, 16? So in yellow there, if you're curious what this will look like, type that into your calculator. And I do need you to add one extra step. when you're done entering both of those in, I need you to hit the zoom button and change it to, I forget which option it is, zoom square. So you want to change it to zoom square. Why square? Because if you notice, by default, it takes the x-axis and it stretches it out. When you click zoom square, it makes the x and the y-axis nothing stretched out. So it's a perfect square. And if you do that, if you want to mess around with this, then you get a nice, beautiful circle. And that's how you graph it. And that, ladies and gentlemen, is the whole class. So not bad. It's just those 3 reindeer games. I do want to point this out tonight for homework. It's going to give you the option. I'm going to skip to the end here. It's going to give you the option of, skipping this slide. It's going to give you the option of either using Pythagorean theorem or the distance formula. Just use the distance formula. It's so much easier than to pull out a piece of graph paper, graph it, count little squares. That's what you would have to do in order to use the Pythagorean theorem. So just use the distance formula for questions 1 through 12. And that was it. This is an example of, hey, if you graphed it, right, you could use the Pythagorean theorem, but distance formula is just easily done. All right, so there's your homework for tonight. If you have any questions, go ahead and send me a chat or something. I'd be glad to help you. I will see you physically. Well, actually, by the time you watch this video, since no one's watching it live, it's going to be Thursday. So you're going to hear me saying, yeah, I'm going to see you guys tomorrow, when in fact, today is Tuesday for me. When you watch this video, it's probably Thursday. So I've already seen you and you've already taken your PSAT test. I hope you guys did well. Make sure, for those of you who do watch this today, this is Tuesday, that tomorrow you bring in a charged graphing calculator. That's it. See you guys on the next class day.